Hello guys, and today we are going to make another educational video for you guys. Just sit tight. In this video I'm going to explain about inputs in a microcontroller, and I just wanna just connect a very specific kind of LCD to the microcontroller, so you can see and you can write anything on that LCD. And it's a very good thing because after that you can make a very different kind of system with this LCD. You can make a clock, you can make everything, you can make an menu, and it's a very good thing. And of course it is a very simple task, so you won't there won't be any problem, and it's very easy. uh, okay, let's go and see what's should we do. Okay, we are making two pins of this microcontroller as an input, so we can just send a signal from output to our microcontroller. Okay, I just connected two switch to my microcontroller. So if I push this key, the 5 volt from this source comes to the microcontroller, and our pin B.0 will sense a 5 volt, means a logical one is going to microcontroller. So when I just release the key, it's not here anymore. Okay, so this pin should be high Z. High Z means it's not connected to anything, but the microcontroller pin will going to remember its last state, and if it sends 1 even if the switch is not connected. Okay, what should we do then? In this situation we should use a pull up or pull down resistor. Pull down resistor is acting as a component who give our pin another state. So when we released the key, the circuit becomes something like this, and it give our pin a 0 state. So when we push it, the 5 volt go straight to the pin and it's 1, and when we release the key, the 0 comes through this resistor and goes to the microcontroller. Okay, debounce means reading from a key. What key? The key that connected to port B.0. Of course, when you wanna read something, you have to use pin B.0. And if you wanna write as an output to a pin, you should use port B.0 equal to anything. And we say here read from this pin if it became 1 or there's 5 volt on that pin, and then if it was 1, then go to key 1 or any other name. You can just say Alex or anything, and you can use here as Alex. Go to this, jump to this one, and sub is an optional. You can use it or you can just ignore it. But sub means it will go there, and after that it return to this program. So when you use sub, it means it will come back and just go on to the rest of the program. But this one, because it don't have any sub, it goes to here and it never came back unless you just jump it to somewhere else. For example, we write go to K2. And what is K2? K2 is right here. It's somewhere in here. Okay, we write a program that when you push a button, an LED is going to light. So, and the next time you push that button, it's going to be off. Okay, if we push the key on P.1, it goes to Q2. Q2 is here. It means it says, okay, toggle port C.0. What the meaning of toggle? Toggle means if it's 0, it turns to 1, and if it's anything else than 0, it came back to 0. So it's just something between 1 and 0. But if you toggle, for example, any other uh, register, it became 1 and 0. Okay, now each time we push it, it's just make our LED light and off. Okay, the key on the P port B.1. So if I just push it, okay, our resistor is too high, so we just use okay, let's write it again. Okay, if I push it, it become turn on, so our LED is turned on. And if I push it again, it's off. It's on, off. It's on, off. Now what about the next switch? It's on, it's off. But we didn't use any code like toggle. I used in the first key, it goes to sub Alex. In Alex, it says there is a condition. It's a if else condition. In this, it says if port C.1, our output, is 1. If we make it 1 before, or maybe not. If it was 1, okay, then make it 0 unless or else make it 1. So if it wasn't 1, it's 0. So this code doesn't work. It goes to after else. So it turn it on. So if it was on, so this one is okay and it turn it off. But if it was off, so this condition is not satisfied. So it's go to else and it turn it on. It's work exactly like toggle, but we code this toggle with a condition. So you can see you can use any kind of code to write your program. It doesn't matter what you use, but use something efficient. And in this case, we can just write a toggle, an easy toggle, just one in a one line. But in this one, we just wrote 1, 2, 3, 4, 5, 6 line just to do this one line. Okay, I just wrote that to explain you can write your program the way you want, and it's up to you what you choose. Just try to learn everything and use the best code, use the less code because it's really easier, it's faster for your microcontroller, and it works better. And if you want to read it uh, after you just after a year or maybe a 2 year, it's much easier for yourself. Okay, now I'm going to add an LCD to this program. Okay, what type of LCD are you using? Okay, the most common is 16:2. We just configure our LCD to the program. The important pins are RS pins, E or enable pins, and data bus 4 to 7. It's 4-bit LCD. Of course, it can work with 8-bit, but why should we just use 8-bit instead of 4-bit? It's better to work with 4-bit. So we go to our simulation and just connect our LCD to this. In here we just search LCD. In here you can find different. It's 16:2. It's an I2C interface. No, it's not what we want. We want the other one. I'm going to show you in here. Yes. Locate means where you want to start your where you want to start to type or you want to write on your screen. So LCD means writing. For example, we say hello guys. Okay, how about this one? It's the cursor. So there is some code about it. Now it's blink. You see it's blinking and it's off. It's not there anymore. Now I'm going to combine those last codes, inputs and the LCD. And what should I make? I don't know. For example, how about a clock? A real clock. So let's just write something and make a clock. Okay, I'm going to name it not really clock because it's not really a clock, but maybe I told you in the future that this clock has some problem, but it shows us what we want. Okay, now for making a clock, we need, for example, three variables. One for second, one for minutes, and one for hour. So how should we write and how should we tell the program we want to make a variable? It's this code. We set dim. Okay, now it asks us, okay, you want to make a variable with the name of sec or sec, second, as what? As a boolean. A boolean means this variable can just be 1 or 0. When you choose byte, it means it's 8 bits, so it can just be in a range of 0 to 255 or 255. In double, it says uh, it can be from 0 to 35,000 something. I don't remember it, but you can see all of that in a help. Okay, this one gives us the range of our variable. Right now we just want to count from 0 to 60, so it's okay with byte. We say min. Okay, I can't use this variable because it means something else, because it became blue. So I have to change it. For example, MIIN as byte. And if you want to go and make another variable in another line, you just have to write dim at the start. But on the rest of the line, you don't need to write dim. Dim hour as byte. Okay, let's give them an initial state. Oh, we can use this one too. It should be sec. Okay, for easier, I just use S, H, and M. It's much faster. With this semicolon, we can put some variable in a series and we just can show them in one LCD code. So to this point, everything is fine. Increment means s plus plus, or it means s should be plus 1. So let's see what happened now. It means locate it, show it, increment in 1, wait 1 second, and again. Show it, increment after 1 second, show it. For example, we say if s equal to 60, then s should be 0. Then increment m, give our minute a 1, and f. Oh, okay, right now as you can see there is a 9. It's not 9 here, it's not 79. It's just a 9 from the old value, but it didn't gonna from the LCD. So I just say CLS each time you're going to show something. So that problem should be gone. Okay, right now we say if our minute is equal to 60, then it should be 0, and increment hour, and if. This if is here. Now I'm going to check if everything works fine, but I can't wait whole a day and just sit on a computer. So I'm just do a trick, and instead of 1 second I use 1 millisecond just to see if it works fine. Okay, there is a problem with my code. I'm going to double click if oh, this one. No, it's okay. This one is okay. Now everything's fine. Okay, now we're going to check our clock. So it's so fast, even the simulation can show it really good, but it works okay. Okay, now every clock needs an adjustment tool too. We are going to use 2 key in case that we can adjust our clock. one for minute and one for hour. Okay, we just put two keys in our program for adjusting the minutes and hour. But there is a problem with the wait. You see, when the program starts working, when it goes to wait, it stops for one. Uh, it stops for 1 second, and the rest of the program would be in pause. So it doesn't matter how many times in that time you push this button, it doesn't work because it's stayed in the wait. So we should fix it, we should do something about it. I give you an idea, and I'm saying because these two keys should be always functional, we do something. For example, we say use we use another variable. For example, I just call it a as byte. And here I say do wait ms 10 millisecond increment r, and a should be 0 before it goes to this do loop. In this do loop, okay, it's 0. We come here and we say until loop until a equal to the 100. Why 100? Because in this loop it means it's going to repeat for 100 times. It's not infinite. It's going to loop until 100 times. Why 100 times? Because 100 times multiple 10 millisecond mean 1,000 second, and it means a second. So it's just like our wait 1 second, but all the time these two keys are functional and it's working. Okay, now we're going to program it and check our program. It's 50 and it's just working. I want to add 1 to our minute, 2, 3, 4. It's 4, maybe 5. 1 to hour. 22, 23, and it should be 0. Oh, what happened? There is a problem. Oh, did you see that? It must be H. Okay, as you can see, there is maybe 1,000 ways to write this code, and it's up to you which way do you use. I just use this one, and just be creative with your codes. It's the way you talk to the program, and you can do it in a countless way. Okay, and this program is done, and as you can see, it's okay, and just add some other features to it, and good luck, guys.